Assalamu alaikum students. Today our topic is current electricity and SLO of these topics are calculate the cost of energy when given the cost per kilowatt hour. Second SLO is distinguish between alternating current AC and direct current DC. Third SLO is identify circuit components and describe their uses in daily life. For example, switches, batteries, fuses, variable resistors, capacitors. Kilowatt hour. What is kilowatt hour? The amount of energy delivered by a power of 1 kilowatt in 1 hour is called kilowatt hour. It is the commercial unit of electric energy. And the unit of energy is joule, but joule is a small energy unit and the larger unit of energy is kilowatt hour. 1 kilowatt hour is equals to 1000 watt multiplied by 1 hour. 1000 watt multiplied by 3600 seconds. Or when we will multiply 3600 by 1000, it becomes 36 into 10 raised to power 5 joules is equals to 3.6 into 10 raised to power 6 joules, or 10 raised to power 6 joules is equals to 1 megajoule. So it is equals to 3.6 megajoules. That means 1 kilowatt hour is equals to 3.6 into 10 raised to power 6 joules. This is the conversion of kilowatt hour into joules. Formula of this: the energy in kilowatt hour is equals to watt multiplied by time in hours divided by 1000. Watt divided by 1000 is equals to kilowatt. So we can also write the energy in kilowatt hour is equals to kilowatt multiplied by time in hours. Cost of electricity. We can find the cost of electricity by the given formula: number of unit consumed multiplied by cost of 1 unit. Cost of 1 unit means 1 kilowatt hour is equals to 1 unit. Whatever you have kilowatt hour, it is equals to unit. Multiply unit by cost of unit, then you will get cost of electricity. For example, the energy used by the iron for 1 minute is 33 kilojoule at a voltage of 220 volts. How large the current is in the iron? Data is given t is equals to 1 minute is equals to 60 seconds. We have to convert minute into seconds because the SI unit of time is second. Energy is equals to 33 kilojoules. Convert kilojoules into joules because joules is the unit of energy, SI unit of energy. So it is 33,000 joules. Voltage is given, that is 220 volt. What is required? Current, that is I. Formula we have to use is power is equals to W upon T. Power is W is 33,000. Time is 60 seconds. So we get the power 550 watt. Now you have to find the current. The formula of current is P is equals to VI. Rearrange the formula. It becomes I is equals to P upon V is equals to 550 upon 220 is equals to 2.5 ampere. So current is 2.5 ampere. Second example is someone watches TV on average 6 hours each day. The TV is connected to a 220 volt voltage so that the electric current flows through the TV is 0.5 amperes. If the electric company charges $0.092 per kilowatt hour, then what is the cost of using electric energy for TV for 1 month? That is 30 days. So, what is required? Cost of energy. Data is given, time is 6 hours multiplied by 30 because 6 hours daily for 30 days. So total time is 180 hours. Voltage is 220 volt. Electric current is 0.5 ampere. And what is required? The cost per month. Solution. Power of TV formula is P is equals to VI. P is 220 volt. V is 220 volt. I is 0.5 ampere. So power is 110 watt. Electric energy is equals to electric power multiplied by time. Electric power is 110 watt multiplied by 180 hours. Watt 19,800 watt hours. Convert into kilowatt divided by 1000, it becomes 19.8 kilowatt hours or 19.8 kWh. The cost of using electric energy for TV during 1 month, 19.8 kilowatt hour multiplied by cost of 1 unit, that is 0.092, it is equals to $1.8216. This is the cost of using electric iron for TV for 1 month. Second is distinguish between alternating current and direct current. Alternating current, which changes its direction in many times in 1 second, is called alternating current. It can be produced by AC dynamos or AC generators. It can be easily converted into DC or AC with less frequency is more dangerous than the same having the same voltage. DC having the same voltage. All right. Again, AC with less frequency 50 Hertz in is more dangerous than the DC having the same level of voltage. Direct current. The current which flows always in one direction is known as direct current. It can be produced by DC generator or batteries. It cannot be easily converted into AC. This is not DC, it is AC. DC is less dangerous than the AC having the same level of voltage. Now next SLO is identify the circuit components and uses in their daily life. First circuit component is switch. A switch is an electrical component that can disconnect or connect the conducting path in an electrical circuit, interrupting the electric current or diverting it from one conductor to another conductor. The symbol of switch is this. It is open switch and one it is close. Okay, close switch and it is open switch. That means current is not flowing. In this case, current is flowing. These are the pictures of the different types of switches available in the market. Second component is battery. A battery is a source of energy which provides a push, that means a voltage, of energy to get the current flowing in a circuit. Or a battery is a device that converts chemical energy into electrical energy in the form of voltage, which in turn can cause current to flow. This is the symbol of the battery or cell. Two terminals in cell and there are more than two cells. It is called battery. This is the symbol of the cell or battery. And these are the different types of batteries or cell. Third component is fuses. Fuses is a safety device which is used to protect an electric circuit against excessive current. It consists of a wire that will melt at a certain temperature. The wire is usually made of an alloy of tin and lead. That means fuses are a safety device which is used to disconnect the circuit when excess amount of current is flowing through the circuit, and it prevent our expensive appliances from burning. This is the symbol of fuse and these are the picture of the fuses. Variable resistor. There are two types of resistor, fixed resistor and variable resistor. Fixed resistor has the fixed value of resistances, but variable resistors are those resistors in which we can change or vary the value of the resistances. A variable resistor is a type of resistor whose electrical resistance value can be adjusted on demand. A rheostat is a variable resistor which is used to control current. They are able to vary resistance in a circuit without interruption. It uses only two connections even when three terminals like potentiometer are present. This is the symbol of the variable resistor. Both are the symbol of the variable resistor and arrowhead. This is also resistor and arrowhead. So these are the symbols of the variable resistor. This is potentiometer and this is rheostat. Both are the variable resistors. Capacitors. Capacitor is the basic storage device to store electrical charges and release it as it is required by the circuit. These are the pictures of different types of capacitors and this is the symbol of the capacitor. Okay, these are the capacitor. We learned about the capacitor in the previous chapters, mica capacitor, paper capacitor, electrolytic capacitor, different type of capacitors. This is the diagram, the electrical circuit diagram in which different components are used. This is battery, key or switch, rheostat, resistor, fixed resistor. This is variable resistor, symbol of variable resistor, and this is fixed resistor, ammeter and voltmeter. Okay, the symbol of ammeter is A and the symbol of voltmeter is V. In this the circuit diagram, you see ammeter is connected in series. You see, this is the diagram in series. Ammeter is connected in series in the circuit, but voltmeter is connected with parallel to the resistor. If we are if we are using to find out the potential difference of this fixed resistor, then we have to connect it parallel to the component or resistor. So always remember, ammeter is connected in series in the circuit and voltmeter is connected in parallel in the circuit. Thank you, girls and boys.